Hi friends, today we are going to see about 0-1 knapsack using dynamic programming. A given n elements of known weights W1, W2 till Wn and the values V1, V2 etc. and the knapsack capacity is W. We can find the solution for 0-1 knapsack by two ways, without memory function and with memory function. And knapsack can be solved using dynamic programming. Here we use three formulas to find the knapsack. The first formula is f of 0, j equal to 0 and f of I, 0 equal to 0. The second formula is f of I, j equal to max of f of I minus 1, j, vi plus f of I minus 1, j minus wi for all j is greater than wi. The third formula is f of I minus 1, j for all j less than wi. Here we can discuss an example problem. Here 4 items are given with corresponding weights and values. The knapsack capacity is given as 5. We have to consider the item from 0 to 4 and weight from 0 to 5 since the capacity is given as 5. We have to construct a matrix box using these values. Now we have to construct a matrix box from 0, 1, 2, 3 and 4 for items and for weights 0, 1, 2, 3, 4 and 5. We have to use the first formula to fill the matrix. F of I, 0 equal to 0 and f of 0, j equal to 0. I is from 0 to 4 and j is from 0 to 5. So f of 0, 0 equal to 0, f of 1, 0 equal to 0, f of 2, 0 equal to 0, f of 3, 0 equal to 0, f of 4, 0 equal to 0. Similarly, for f of 0, j. Now we have to fill the matrix box of 0, 0 equal to 0, 0, 1 equal to 0, 0, 2 equal to 0, 0, 3 is equal to 0, 0, 4 is equal to 0 and 0, 5 is equal to 0. Similarly, here also. To fill the rest part of the matrix, we have to use the other two formulas. To fill the value 1, 2 in the matrix, f of 1, 2 equal to I equal to 1, j equal to 2, v1 equal to 12 and w1 equal to 2. The value of v1 and w1 is selected from the given table. For the item 1, w1 equal to 2 and v1 equal to 12, which we assigned here. Now we have to check the j value and w value. If j value is greater than w value, we have to use the second formula. Here j value is greater than or equal to w value. So we have to use the formula f of I, j equal to max of f of I minus 1, j, vi plus f of I minus 1, j minus wi for all j greater than or equal to wi. So we substituted the value in the given formula. So f of I minus 1, j, I value is 1, so 1 minus 1 is 0 and j value is 2. vi is 12 plus f of I minus 1, j minus wi. So I value is 1, 1 minus 1 is 0, j value is 2 and wi value is 2. So 2 minus 2 is 0. So max of 0, 12. So we put the value 12 and we have to fill the value of 1, 2 as 12 in the matrix box. For 1, 3, f of 1, 3 equal to I equal to 1, j equal to 3, v1 equal to 12, w1 equal to 2. Now we have to compare the j and w1 value. J is 3 and w1 is 2. 3 is greater than or equal to 2. So we have to use the second formula. So max of f of I minus 1. I is 1. 1 minus 1, 0. J is 3, vi. Vi value is 12 plus f of I minus 1, j minus wi. I is 1. 1 minus 1 is 0. J is 3 whereas w1 is 2. 3 minus 2 is 1. So max of 0, 12. Again the value is 12. Now we have to fill the value of 1, 3 in the matrix box as 12. f of 1 comma 4 equal to I equal to 1, j equal to 4, v1 equal to 12, w1 equal to 2. Here the value of j is 4 and value of w1 is 2. J is greater than w1, 4 is greater than 2. So we use second formula. So f of I minus 1 comma j, I value is 1. So 1 minus 1 is 0 and j value is 4. v1 is 12 plus f of I minus 1 comma j minus wi. 1 minus 1 is 0. J value is 4. 4 minus 2 is 2. So max of 0 comma 12. Again the value is 12. So we have to fill the value of 1 comma 4 in the matrix box as 12. For f of 1 comma 5 equal to I equal to 1, j equal to 5, v1 equal to 12, w1 equal to 2. The value of j is greater than w1. So again we use the second formula. So f of 0 comma 5 comma 12 plus f of 0 comma 5. So max of 0 comma 12 which is equal to 12. So we have to fill the value of 1 comma 5 in the matrix box as 12. Now we have to find the value for the second item. F of 2 comma 1 equal to I equal to 2, j equal to 1, v1 equal to 10, w1 equal to 1. The value of v1 and w1 are assigned from the given box. For second item, w1 equal to 1 and v1 equal to 10. That is what we assigned here. Now we have to compare the value of j and w1. Value of j equal to 1 and w1 equal to 1. 1 is greater than or equal to 1. So we use the second formula. F of 1 comma 1 comma 10 plus f of 1 comma 0, max equal to 0 comma 10 which is equal to 10. So in the matrix box we have to assign the value for 2 comma 1 as 10. For f of 2 comma 2 equal to I equal to 2, j equal to 2, v1 equal to 10, w1 equal to 1. J is 2 and w1 equal to 1. 2 is greater than or equal to 1. So we are using the second formula. F of 1 comma 2 comma 10 plus f of 1 comma 1 which is equal to 12. So in the matrix box for 2 comma 2 we have to assign the value 12. Similarly for f of 2 comma 3, I equal to 2, j equal to 3, v1 equal to 10, w1 equal to 1. J is 3 and w1 is 1. 3 is greater than or equal to 1. F of 1 comma 3 comma 10 plus f of 1 comma 2, max of 12 comma 22 which is equal to 22. So in the matrix box for 2 comma 3 we have to fill the value as 22. For f of 2 comma 4, I equal to 2, j equal to 4, v1 equal to 10, w1 equal to 1. J is 4 and w1 is 1. 4 is greater than or equal to 1. So the condition satisfies the second formula. So f of 1 comma 4 comma 10 plus f of 1 comma 3, max is equal to 22. So in the matrix 2 comma 4 we have to fill the value 22. Similarly, for f of 2 comma 5 equal to I equal to 2, j equal to 5, v1 equal to 10, w1 equal to 1. J is greater than or equal to 1. F of 1 comma 5 comma 10 plus f of 1 comma 4. So max of 12 comma 22. Therefore, the max value is 22. So in the matrix for 2 comma 5 we have to fill the value 22. Similarly, for third and fourth item, we have to follow the same steps and find the values. After filling all the values in the matrix box, we have to select the greatest value which is 37 that is generated by f of 4 comma 5. We have to use the formula f of I comma j not equal to f of I minus 1 comma j. Here 4 comma 5 not equal to the value generated by f of 3 comma 5 that is 37 not equal to 32. So fourth item is selected. For next iteration we use the formula I equal to f of I minus 1 and j equal to j minus wi. For the fourth item the value of wi is 2. So for I equal to 3 and j equal to 3. So for next iteration f of 3 comma 3 not equal to f of 2 comma 3 should be checked. Here both the values are same, so the item is not added. By following these steps, the final answer is the items with 1, 2 and 4 is added in the knapsack and the profit is 37.